So for this video, we're going to be using the same function as I have used in the prior video, but we're going to be explaining the first and second derivative tests. So the first derivative test will give you the slope of the original function at the certain point that you would plug in. So if you were to plug in you're plugging in x equal 5, you would be unable to find that. But as I'm going to turn on the first derivative, which is orange, now we are going to be able to find things. So if we were to see, let's see first derivative test at x equals -2. So we're going to do x equals -2, and we're going to find a -2 for the first derivative, x equals 3, or y equals -3 and x equals -2, my bad. So, and then to prove this, we're going to do a y equals, and this is to prove that the first derivative will give you the slope at a certain point, 3x. And then you have to realize that you have to connect with what this is. So we're going to do 3x minus 2. Or no, it would be plus 2. And then we are going to minus 3. And if you were to zoom in, sorry for all the confusion with all the colors, but if you zoom in here, at this point, this slope is exactly going with the first derivative at x equals -2. And that proves that if you were to plug in a point onto the first derivative, it will give you the slope. Now I'm going to turn that off, and we're going to be able to do the second derivative test. So I'm going to zoom out. And then here is the second derivative. The second derivative is green. And then if you were to plug in a point onto the second derivative, you're able to find whether it is going concave up or concave down at a certain point. And if you look on this graph, if I am to plug in, say, let's not do x equals -2. Let's do x equals, let's do x equals 4, or -4 actually. And we're going to turn that on. So you can see here, sorry for making the screen. I'll make that red, so it's more definitive. So second derivative is green, and if we go here, the number on the y-axis is negative. And for the second derivative test, all you're looking for is whether it's negative or positive. And if it's negative, it'll show concave down. But if it's positive, it'll show concave up. So at x equals -4, the original function is concave down. And you can also use this to find the relative extrema. So if you can see on the second derivative where the inflection point, or where second derivative equals 0, which means the inflection point is at -2 2/3. And then if you see here, you can, using this, you can find the exact, or you can find the extrema, where the coordinates of this are right here. And then now you can save the coordinates of the inflection point. And then you can also do this with the first derivative test. So I'm going to turn off the second derivative really quick. And we turn that off. Now inflection points there. And then for the critical points on this one, you can see where this equals 0. And where this equals 0, you can create lines that would show you, or use this, plug it in, and create that. And you can use this to show you the coordinates, or you can plug that into the main function. and that would give you the x-coordinate and would give you the exact coordinate of the relative extrema. And then you are also able to do this with, now is the relative maximum, you can do this with the relative minimum. And you can find the exact coordinates. And this is the many ways you can use the first and second derivative test. Thank you for watching.